Hello, everybody. Hi, everybody. We're doing volume of right pyramids and cones today. I'm sorry I can't be there, but I'm there in voice, and we're going to have an exciting discussion. Well, me talking and you listening about finding the volume of cones and right pyramids by connecting them to prisms and cylinders, which you already know the equations for the volume of prism and cylinder, or you should from junior high, but we'll review that today also. First thing I want you to do is go and watch a video, which the link is on Blackboard. It's a YouTube video, so pause this video, go watch that YouTube video, turn down your volume because there's a lot of background noise, and you don't need to hear everything, you just need to see the visuals. So please do that, pause this video, go see the YouTube video, and then come back and we'll have a discussion about the video that you're watching on YouTube. Hi everyone, so you went and watched that video for me on YouTube and it was really interesting. You saw that there was it took three of these pyramids that have the same base area as the prism and the same heights of both objects. It took three of these pyramids to fill one of those prisms. So by knowing that, we know the volume of a prism is height times width times length, which we have there. But since it took three to fill one, we know that the volume of a pyramid must be only 1/3 of that. So the volume of the pyramid is only 1/3 of the volume of a prism. So we just stick this 1/3 in front of all these multiplications here. So this is the formula that you need to know in order to find the volume of a pyramid. So let's do an example question here. This one right here is a little bit more tricky. And so we know the volume of a pyramid is 1/3 height times width times length. Now our width we see is 4 inches. We're told that it is a square base, so we know that the width and length will be the same, so the length will be 4 inches. But here what we're stuck with is we don't know what the height is right away. We know what this slant is, but remember the height is actually that toothpick that falls straight from the top of the pyramid to the center of the base. It creates that right triangle, which we've already talked about, and we can use Pythagoras' theorem to find the height. So let's pull out that triangle and draw it. So we know the slant is 6 inches. Now halfway between each edge of the base of the pyramid, that's where this toothpick falls to tell us how high the pyramid is. Now halfway if we know the whole length is 4 inches, then half of that would be 2 inches. And what we're trying to find here is this value right here. This is going to be our height. So let's label it as a, so it's easy. So we have a squared plus b squared equals c squared, because that's Pythagoras' theorem. So a squared plus 2 squared equals 6 squared. So a squared equals 4, 36, and we get a squared equaling 36. Subtract 4, which is 32, and we can take the square root of both sides, so we get a equaling 30 square root of 32. Now we're going to keep the square root here, so we don't lose accuracy of the number, because if we take a decimal point, it's really truly not the full number that we're dealing with. And square roots are not that scary to work with. So now that we know that h equals a, which equals the square root of 32. I hope everybody gets that right now. If you don't, we rewatch this video and you'll probably get it really quickly. So the volume of the pyramid equals 1/3 height times width times length. So let's just fill everything in. 1/3 our height is the square root of 32, and that is inches, times our width, which is 4 inches, and times our length, which is 4 inches. So we put inches in all the way so we don't forget what we're dealing with, what units. Now when you type that into the computer, the square root of 32 times 4 divided by 3, you're going to get just over 30 inches. So we're going to say approximately 30 inches. Now, it's 30 point, I think it's 30.05 or something like that. But the 30 inches, we round to the full inch because it's 30 inches cubed, sorry. We round to the full inch cubed because we do not want to have decimal numbers with imperial numbers. So now that we're doing measurements and we're doing calculations, we're going to approximate, always use the approximate number because you do not use decimals when you're doing imperial units. Okay, so inches cubed because it's inches times inches times inches. That's how you get inches cubed. Okay, I hope I didn't confuse anybody there. But we're just rounding to 30 inches cubed because in imperial units we do not use decimals. Here's just another simple little problem. We have a pyramid and it tells us the dimensions. So it tells us the base is 36 by 7. So this tells us this is 36 meters by 4.7 meters. And it tells us the height of the pyramid is 6.9. And since it tells us the height, we do not need to use Pythagoras' theorem here. So our width equals 4.7, and our length equals 3.6. So very easily, we're able to calculate that quickly. 1/3 height times width times length. So 1/3 6.9 meters times the width, which is 4.7 meters, times 3.6 meters. So let's type that in. 6.9 times 4.7 times 3.6 gives you 116. Divide by 3 will give you 38.92 meters cubed, because we have meters times meters times meters, which is meters cubed. Why are we allowed to use a decimal here? Because in metric we are allowed, in imperial we are not. So I hope that helps everybody right there. From now on, we will be just using approximates, so fractions, or rounding to the full inch or inch cubed in imperial, but we will be using the decimals with the metric. Okay, so using the same type of thinking here, we know the volume of a cylinder equals pi r squared h. Now it takes 3 of these cones that have the same area base and the same height as the cylinder to fill one of those cylinders. So for a volume of a cone, we have the same relationship where we do 1/3 the volume of the cylinder. So 1/3 pi r squared h. So here's the other formula that we'll be using today. Volume of the cone equals 1/3 pi r squared h. Here's a simple question here. Determine the volume of this cone to the nearest cubic meter. It's not that hard, but you do have to remember, guys, that the diameter is 8 meters here, and we're looking for the radius. And the diameter is 2 times the radius. So in order to get the radius, we have to take this diameter and divide it by 2. So 8 divided by 2 would be 4 millimeters. Our height here is given to us where we drop the toothpick down and it hits, which is 13 millimeters. Okay, so volume of cone equals 1/3 pi r squared h. So 1/3 pi r is 4 millimeters squared. H is 13 millimeters. So let's go to our calculator and I'll show you exactly what you have to do here. Let's minimize that. So we have 4 squared is 16 times 13, 208, times the pi button. You cannot type in 3.14. You have to multiply by the pi button on your calculator. That'll give you 653.45, and we're dividing by 3, which is 217.82 millimeters cubed. Okay, the last example question that I'm going to go over today with you is this one right here, which is a little bit more difficult. So we're given that the volume of the cone equals 205 cubic yards. And we're told that the height equals 4 yards. And we're asked to find the radius. Correct? Yes. So, the volume of the cone equals 1/3 pi r squared h. So we have to be able to rearrange this equation to isolate r. So this is what we're going to do. 1/3, so dividing by 3 is what multiplying by 1/3 is. So the opposite of doing that is multiplying by 3. So we have 3. We multiplied this side by 3. So this cancels with that because 3 divided by 3 is 1. Now we have to isolate r here too. So pi and h are multiplied. So the opposite of multiplication is division. So we divide by pi h on both sides. Pi divided by pi is 1. H divided by h is 1. So we're left with 3 times the volume of the cone divided by pi h equals r squared. Now how do we get rid of the square? The square root. So r equals the square root of 3 times the volume of the cone divided by pi h. So let's fill everything into there. 3 times the volume of the cone, which is 205 yards cubed, divided by pi. 4 yards is h, filling in 4 yards for h. And remember to press pi button on your calculator. And when you do that, you get 6.99 blah, 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 blah yards. Now we're dealing in imperial units, so we want to round up. So we have approximately 7 yards is our radius, and that is our final answer. Okay, everybody, these are the questions that you have to do, 8, 9, 10, 11, and 18 on pages 42 to 43. Please finish these in class with the remaining time. You should have about just over a half hour, 35 minutes probably, to complete these questions. And if you don't understand, I will be in for extra help on Monday morning at 7:30 and at Monday at lunch. So, finish up these questions, work hard, and be good. And we'll see you tomorrow by voice, but Monday in person. Have a great day, guys.